I'm Bob Morris-Lecar, and this is my electronic implementation of a single Morris-Lecar neuron model. Okay, so here's the circuit. First of all, the Morris-Lecar model has three different membrane channels. It's got a leak channel, which is just a constant resistance, and that's given here by the battery here. This is the leak voltage, 1.2 volts, and then just a fixed resistance for the leak channel. And then we've got a potassium channel, which is this section of the circuit here, which is again 1.2 volts, but this time the resistance can change. And the way the resistance is changed is with this chip here, which is with a digital potentiometer chip. So that's changing the resistance of the channel dynamically. And then the same here, we've got another channel, which is calcium, but this is much higher voltage. This is 4.8 volts. And again, the resistance is being changed by the potentiometer. And controlling the whole thing is this microcontroller board here. This is a teensy board. What this is doing is it's constantly sensing the current membrane voltage through this wire here, and then it's sending messages via SPI to the two potentiometers to update their resistance according to the Morris-Lecar equations. And then finally, just up here, I've got a cheap USB oscilloscope to measure the current membrane voltage, which is what's shown on the screen here by the yellow line. Currently it's not really doing anything because I'm not providing enough current into the neuron to cause it to do anything. But if I increase the injected current slightly, which I can do by sending a message over the USB, just put it up one step, not enough, 2 steps, here we go. So now you can see it's kind of starting to intermittently fire these spikes, but it's kind of not doing it reliably. It's just because it's a noisy circuit, occasionally it will spike and occasionally it won't. But if I increase the current some more, we'll see we'll start to get reliable, regular spiking here. And if I increase the current even more, you'll see that the frequency of the spikes increases. Just like if you were to run a simulation of the model on a computer.
Very good.
And that's it.